The thermocouple vacuum gauges, they are used for the measurement of pressure and they work on the principle of thermal conductivity. The thermal conductivity, it is a function of the pressure. So this principle is being used here. So indirectly the pressure is measured by measuring the thermal conductivity of the gas. Now, because its name is thermocouple vacuum gauges, so these gauges, they consist of a thermocouple. Okay, so the main part is thermocouple, and we know that thermocouple is used for the temperature measurement. Okay, so here we are going to measure the pressure by measuring the thermal conductivity. Thermal conductivity means that gas is having some molecules in it. Okay, so as the temperature increases, the molecules, their thermal conductivity also increases, and if there is a change in the thermal conductivity, then pressure is also a function of thermal conductivity. Okay, so pressure also changes. So indirectly what we will do, if there are any changes in the pressure, then thermal conductivity of the gas will change, and thermal conductivity changes means that there are changes in the temperature also. Okay, now let's see the construction of the thermocouple type of vacuum gauges. So this is the construction or the diagram for the thermocouple type of vacuum gauges. Here you can see that we are having a box, and in this we are having a heater element. To this heater element the thermocouple is attached. Thermocouple, it is a combination of two dissimilar metals, and it works on the principle that when two dissimilar metals, they are combined, that will form two junction. One is the cold junction, one is the hot junction, and as the pressure changes, the output voltage also changes. Okay, as the temperature of these two junction changes, the output voltage also changes. So here thermocouple is there, we are having the two junctions of the metals. Okay, and to this moving coil millivolt meter is attached, which is going to measure the output voltage. Now here we are having metal or glass envelope in which the gas, which is at vacuum pressure or which is at vacuum, it is kept. and here we are having heater element. So thermal conductivity is also going to change due to the pressure, and also temperature changes are also going to be made here. Here we are having battery and the rheostat. Now let's see it's working. So the main parts are the heater element, which is heated at a temperature of 50 to 400 degrees Celsius. Which is in contact with this heater element at its center. So you can see in the diagram also that the thermocouple, it is kept at the center of this heated element, okay, and all this thermocouple and heater element combination, it is placed in a metal or glass envelope. Now, because this heater element is to be heated at a temperature of 50 to 400 degrees Celsius, so to this heater element the constant current is being passed, and its temperature depends upon the amount of heat which is radiated, or which it is surrounding. So the temperature of this heated element, it depends upon the amount of heat which is lost to the surroundings. Okay, so if more heat is being lost, its temperature will be less. If less heat is lost, then its temperature will be more. Okay, so this heated element is going to give its energy to its surrounding. Okay, and this heat is lost either by the conduction or by convection. Now, as we have said here, that temperature of the heated element, it depends upon the amount of heat which is lost to the surroundings. Now, if we are having pressures below 10 raised to the power minus 3 mmHg, that is vacuum pressures, so at that pressures ranges, the temperature of the wire is a function of the pressure of the surrounding gas. Okay, so we are having the heated element there, so its temperature is going to depend, or it is a function of the pressure of the surrounding gas. Okay, so by measuring the temperature, we can measure the pressure of the gas, and temperature can be measured by the thermocouple. Okay, so thermocouple, because in thermocouple we are having two junction, hot junction and the cold junction, and because there is a difference in temperature, so there is a difference in the thermal or the EMF which is generated there. Okay, so the more the difference in the temperature, more will be the EMF generated, and that EMF generated can be measured by this moving coil millivolt meter. Okay, so thermocouple, because temperature of this heated element is changing because of the pressure of the gas surrounding it, and temperature changes are measured by this thermocouple and giving us an output. Okay, so output is a voltage and input is the pressure changes. Okay, so in the diagram you can see that we were using the moving coil the millivolt meter to measure the output voltage. So this moving coil instrument may be directly calibrated to read the pressure. So if we see its complete working, what is there in the thermocouple vacuum gauges? First, the heater element is heated up. Okay, the temperature of this heater element, it depends upon the current which is flowing. So current can be changed by changing the settings of this rheostat. Okay, so the temperature is changing, due to that the pressure is also affecting this temperature. Okay, that how much heat is being lost, it depends upon that how much heat it has radiated to its surrounding gas. Okay, now if the pressure is low or pressure is changing, that pressure is affecting the temperature of this heater element, and temperature is changing, so thermocouple is going to detect those changes in the pressure, in the temperature, and then it is going to produce an output voltage, and this moving coil meter can be calibrated to give us the readings of the pressure. Okay, so due to pressure, thermal conductivity of the gas is changing. Okay, or we can say the temperature of the heater element is changing, and due to changes in the temperature, output voltage is changing. So we are measuring the pressure by measuring the output voltage. Okay, and we can see here that a non-electrical quantity is converted into an electrical quantity, so it is a type of transducer also. Now let's see the advantages of this thermocouple vacuum. The first advantage is that they are inexpensive, very simple to use. Okay, and accuracy is also very good. But if we talk about its disadvantages, then its disadvantages are that they are subject to burnout, if exposed at rugged and so the disadvantage is that they are subject to burnout. The heater element is going to burn out if it is exposed to rugged environments. Rugged means continuously we are using it, and the atmospheric pressure, the pressure of the gas is at very high temperature and the current is flowing in it. Okay, so the heater element can burn out in such cases. If we talk about its applications, then we have seen that it can be used for the measurement of very low pressures in the vacuum range. So this was all about the thermocouple vacuum gauges. We saw its principle of working, that its working is based on the thermal conductivity of the gas, which is a function of the pressure. Then we saw its construction, that it consists of a thermocouple and heater element. And then we saw its working, that how by measuring the output voltage we can measure the pressure variations. And in the last we saw its advantages, disadvantages and its applications. So I hope that this topic is now clear to you. Thank you.